The universe is expanding. If you zoom out far enough, you'll find that everywhere in the universe is moving away from everywhere else. But once you know the universe is expanding, you might wonder if it's going to keep expanding somehow, or eventually stop and crunch in on itself because of the attractive force of gravity. Well, all you have to do is point your telescope at a distant galaxy, measure how fast it's moving away from us, wait about 1 million years, and then do the same thing again to see if the galaxy is moving faster or slower than before. But if you don't have 1 million years to spare, here's what you do. You look at different galaxies. Because light takes time to reach us, when we look at a galaxy far, far away, we see it as it was a long time ago. So looking at a bunch of galaxies different distances away is kind of a rough proxy for looking at the same galaxy at different times. The light from the stars in a distant galaxy can tell us 2 basic things. First, its speed. Light from anything moving away from you becomes redder in color, kind of like how police sirens get lower in pitch when moving away. This red shifting of light tells us exactly how fast stars are moving away from us. If the light from a star is 5% redder than it should be, it means the star is moving away from us at 5% the speed of light. Light can also tell us how far away a star and its parent galaxy are. When you're driving at night, you can tell how far away a motorcycle is by comparing how bright its headlight seems to you to how bright it would be if you were right in front of it. The same trick works with stars. There's a rare kind of supernova explosion that's like a standard interstellar headlight. It's about 5 billion times brighter than our sun, and crucially, it's very consistent in its brightness. These supernovas only happen a few times in a galaxy every 1,000 years, but there are enough galaxies in the universe that if you look closely at a wide enough patch of sky, it's possible to see 12 of them go off in a month. By comparing the brightness as seen here on Earth with how bright we know each of them should be, we can work out how far away each supernova is. The dimmer its light, the farther away it is. So the color of a Type 1a supernova tells us how fast it's moving away from us, and its brightness is like a ruler, telling us how far away it is. Or, because light takes time to get here, how long ago we're measuring its speed. By measuring the speeds of different supernovas at different distances, aka different times in the past, we can plot the expansion of the universe over time. A straight line means the universe is expanding at a constant rate. A curve means it's speeding up or slowing down. For a long time, we thought the line was straight, or slightly curved in the slowing down direction. But when astronomers finally looked carefully at supernovas in super distant galaxies, they discovered to their surprise that the universe is expanding faster now than it was long ago. The universe's expansion is accelerating. P.S. We have a few basic ideas for why the universe is accelerating, but we still don't really know why it's happening. One of the simplest and most popular ideas is that there's an everywhere permeating vacuum energy with negative pressure, which we've never detected in any way other than by measuring the acceleration of the universe. So we call it dark energy. Thanks to the Wide Field Infrared Survey Telescope project at NASA Goddard Space Flight Center and the Space Telescope Science Institute for supporting this video. WFIRST is planned to launch in the mid-2020s and will, among other things, allow us to see a much wider swath of the sky at Hubble-like resolutions and even farther distances, and thus hunt for more supernovas many billions of light years away. That'll help us understand whether the acceleration of the universe is different in different parts of the universe or whether it's changed over time, which should help us figure out what exactly dark energy is.